la 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 la. Alright, here we are doing some free body diagrams. This is homework 13. We got a four-way tug-of-war at TJ. Each class is rope attached to a stout ring, and they all go in different directions. So let's go ahead and draw us a little picture here. There's our stout ring. Yep, nice and stout. I'll put an S in the middle just so we know how awesomely stout it is. Freshman, apply a force of 2220 newtons due south, so I will do 2220 newtons. I'll call that F, I don't know what I would call it, F9. Freshman, you know. Okay, sophomores, 2830 due north, so I'll go F10 equals 2830 newtons right there. F9 equals that. Juniors go 3250 due east. F11 equals 3250 newtons. And then the seniors must apply an unknown force just large enough in the right direction to keep the ring from moving. Okay, so let's say we're going to, the seniors, well, let's see. Yeah, so let's just do like the seniors doing some crap there. And we'll say it's at an angle theta. Okay, so we'll call that F12. Oops. So F12 equals what? Theta equals what? Okay, but really we just want to draw the free body diagram. So, free body diagram for the ring. Okay, for the ring. There we go. Okay, so we start by defining our coordinate axes. We are going to easily just take the the easy way out and go X, Y. So over here, for our free body diagram, we go Y, X. Perfect. So let's start by drawing the forces on our main free body diagram. Let's start by doing F12, since that's the one we is gonna it's gonna crowd the coordinates over here. Not really. Okay, there's F12. There's F10 equals 2830 newtons. Look up an arrow on that. F11, which is the juniors, 3250 newtons. And F9, that's not a 9, that's a G. Alright, F9, that's a little better, is 2220 newtons. So the seniors, right, so then we got to do this component, componentization thing. So we do our second one. I'm going to put it down here. So the non-seniors are all going along coordinate axes. So F10 equals 2830 newtons. Horrible handwriting, I know. Okay, F11, just copy over also, 3250 newtons. And F9 is, not G, F9 is 2220 newtons. And then we have to split F12 into horizontal vertical components. So let's go with F12. This is going to be F12 cosine theta on going horizontally, because they're at theta from the horizontal, so the cosine goes horizontally. And then the other one, that was perfect, and I hit the right mouse button. All right, then this one in here is F12 sine theta, right in there. So there are our free body diagram forces, both the component version and the regular version. Notice we've got the coordinate axes, we've got things labeled, everything's coming outward. The second one's broken into components. Handwriting is sloppy, but we're not going to grade on that, fortunately. So that's it for number one. Let's go ahead and I'm going to do problem 2 here. I'm going to scroll down and get us a free spot of screen. So problem 2. That's where we have, it's a pirate sign again outside the little tavern. So we've got those two things hanging from those hooks, and this is theta 1 in here, theta 2 over here, and they're both attached to this cannonball here on top, which is the sign. Let's see the sign. Yeah, I'm just going to say the cannonball on the side is one thing, so it's an Avast Me Hearty, so AMH we're going to put there. So there we go. And let's do our free body diagram. So we've got, first of all, let's do our forces. I'm going to do forces in red. So we've got a weight here of the sign, right? So this is going to be mass of the sign times G. We've got a tension from these two cables. each cable does a tension. So I'm going to do tension 1 here, and this side tension 2. All right, easy enough. So let's do a free body diagram for the sine. There's no other forces here. The sine's not touching anything, so there's no normal force. There's just gravity and tension. Okay, so free body diagram for the sine. Let's do our coordinate axes there. Whoops. There we go. X, Y, X. I'll put arrows on them. Y. Okay. So first we got our cannonball, or well, we represent it as a dot. Okay. So then we've got our T1 pulling up that way, T2 pulling up that way, and MG going straight down. So let's draw our horizontal. There's our angle theta 2. So yeah, this angle in here is theta 2. So if we draw a horizontal axis there, this in here will be theta 2. That's why we say over here, this is pulling theta 2. And T1 is pulling at theta 1 from the horizontal 2. I mean, the horizontal also, not horizontal 2. Okay, so let's do this. There's our second one with components. Weight, very simple, mg. And then we have here, let's see, so this T1 cosine theta is going to go to the left because it's an angle from the horizontal. So this is T1 cosine theta. And then we're going to have T1 sine theta going up there, up here. Oh, I'm sorry, sine theta 1 and cosine theta 1 for T1, obviously. Okay, and then going up we have T2 sine theta 2. And to the right for this one, we have T2 cosine theta 2. Again, the angle's from the horizontal, so the horizontal gets the cosine. Whatever the angle is being measured from is the axis that gets the cosine. Cosine goes to what you're measuring from. Sine goes to the other one. And so that is complete, number 2, and that's 7 minutes. So I think I'm just going to stop there, and we'll start a new video for 3.